So in the last video, we talked about variables, these labeled boxes that store information. Now we're going to answer a very important question, which is, how does a game actually know where anything is? So let's recall what we were doing with variables in the last video. Before, we had something like my health equals 100. And that worked because your character's health is a single number. Your position has a little more going on. So if I asked you, where are you right now? You can't really give me a good answer by just saying like 10. That's not enough information. I need more than that to locate you. So imagine a piece of paper, or in our case, a whiteboard. If we want to describe a location on a flat 2D surface like this, how would we do that? Well, first, let's imagine we have two lines. We're gonna have a red horizontal line, which we'll call our x-axis, and a green vertical line, which we'll call our y-axis. It's completely invisible. Add some evenly spaced notches to both lines, and you get what's called a Cartesian coordinate system. Now we need two numbers. We need an x value, which tells us how far left or right we are on our x-axis, and a y value, which tells us how far up or down we are on the y-axis. So the center here is 0, 0, because we're neither up nor down on the y, and neither left nor right on the x. So if we wanted to describe a position to the left or down, we need to use negative numbers. If we want to describe a position up or to the right, then we need to use positive numbers. So we could write something like this: float x equals 3, float y equals 2. This tells us go 3 units to the right, 1, 2, 3, and 2 units up, 1, 2. Now really quick, what in the world is a float, and why are we using it? Well, remember integers, or int? An int is made of whole numbers, like 1, 2, 3. A float can have decimal places, like 1.7 or 2.54. You can be a lot more specific with things that need it, like position. For example, we could do float x equals 3.5 and float y equals 2.5. That puts us in a position now between 3 and 4 on the x-axis and between 2 and 3 on the y-axis. We couldn't access this position if we just use integers. So that gives us a position somewhere in 2D space. In games, we usually group these together into a single variable that holds both values. In a general sense, it would look something like this: position equals 3.5, 2.5. So let's practice this by creating a few numerical positions and finding them on our x and y axes. Try having at least one of each possibility. You can have negative x, negative y, negative x, positive y, positive x, positive y, positive x, negative y. I'm going to come up with a few of these and I'll show you how it should look. So for this first one, I'll do position 6, 5, and that should show up right here. Then for position 4, negative 2, that should show up over in this quadrant. And then position negative 1, 6 will show up right here. And lastly, position negative 6, negative 3 will show up right here. Each of these sections is called a quadrant, because there's 4 of them. Pretty straightforward. So now we have an understanding of the basic concept behind positions in 2D space, but what about 3D? Well, the principle is the same, but we add one more value along a new axis, which we call z. So if x is left and right, and y is up and down, z is forwards and backwards. It's going to give us depth. We can take exactly what we did before, but add a third number. We could say position equals 3, 2, 5. And remember, they're alphabetical order, so it's going to be x first, then y, then z. So that would mean that we're going to go 3 units to the right, 2 units up, and 5 units forward. So the position is somewhere out here in 3D space, right? Now you can imagine how you would use this in a game where your enemy might be positioned at 10, 0, 0, and your player might be at 0, 0, 0, in which case the enemy is going to be 10 units to the right of wherever the player is. Make sense? So every object in a game works like this. Player, enemies, projectiles, coins, even the camera has a position. And these positions can change. So if an enemy is walking towards you, their position is updating, it's changing. When a projectile flies through the air, its position is constantly updating very quickly. So, to sum up, a position is a variable that holds multiple numbers that describe where something is in either 2D or 3D space. Now that we know how to store that position, how do we actually make something move? In the next video, we're going to learn just that.